Well, hello, everybody. Welcome to Midweek with Max. This is Jeremy Nation filling in for Rick, who's taking a much-needed vacation to get some rest and relaxation that he, well, let's face it, it's well-deserved. And Max can bring us our engineering updates in the meantime.
All right, cool. Thanks, everyone, for joining another Midweek with Max. A couple of engineering updates. I've been making a lot of progress on the Opereth ZK proving side, so working through some optimizations on the Oxygen ZK VM guest for some edge case sort of denial of service type scenarios in Bitcoin blocks, kind of like the old N squared ECDSA script verification, script hashing. So getting those in, doing some testing on those, and looking at some worst case performance metrics, we can grade the ZK proving marketplace and the way that the protocol prices jobs correctly. Aside from that, we're also about to roll out our opgeth hardening release, so doing some more internal testing and some minor tweaks on that. Beyond that, also making progress on formerly Monify, now Fast Track, as Jeremy will remind me if I get it wrong. So that's coming together, and we're getting those PRs in and reviewed. Let's see, aside from that, been making some improvements on the ZK Miner, ZK Marketplace side. I'm waiting on some contracts to deploy. If they deploy and everything works as expected, I might be able to do a demo later in this call. If not, we can do that as a breakout, maybe as a video on Discord or something. And yeah, I think with that, that's all the major updates from my side. So I'll throw it back to Jeremy for marketing updates and then to start going through questions.
Marketing updates will be real quick. There aren't very many, but do look forward to a forthcoming report that we have coming out that will be describing some of the components of Hemi, their functionality, and how they help to drive yield through stablecoin infrastructures. It's pretty interesting. With that, we can go straight to questions, which have been posted for me to read. I just need to figure out where that is exactly. And I'm very, very good at that. So as you can see, I am absolutely completely ready here and not being caught off guard as I navigate to where those questions are. The first question is asked by Mudakan, who says, what timeline are we looking at for the final tunnel phase going live?
So the two phases we have left is the ZK side of the Ethereum tunnel, and then the ZK side of the Bitcoin tunnel, or the HBit VM design. So for the Ethereum tunnel, we're making progress on that. I'm sometime in Q3. I know that's a little vague because we're already in Q3, and that could be, weeks or months, but probably towards the end of Q3 for the ZK Ethereum side, and then probably Q4 for HBit VM.
All right. And the next question comes from Luctatio, who asks, when will VE Hemi staking rewards be distributed?
It is coming soon. We have everything ready to do it. We just got to get a new contract deployed, and there's been some other engineering priorities with all the ZK stuff we're working on, but we are going to get that done very shortly.
And a follow-up from Luctatio.
Same for pop points. It's also coming very soon. Apologies for the delay. We're got a lot more things to do than engineers to do them, but we are going to be getting both of those out shortly.
The next question from Jones34. What is the current circulating supply of Hemi tokens? I noticed the current reporting circulating supply across all chains is under 1 billion Hemi tokens, but per the original vesting schedule, the current supply should be 3 to 5 billion.
I don't have exact numbers in front of me. I'd have to pull some numbers and do some calculations, so we can talk more details next week. It's certainly below the original emissions, which is like a worst case emissions projection. I do think the stat sites are a bit behind, so we do need to get those updated, but it's again, I don't have exact numbers. We can talk about that next week when I actually get actual numbers to reference, but it is definitely below the original circulating supply projection numbers.
And this would be the shortest section of questions that we've ever come across if we don't get any more. I have a hard time believing that. So perhaps, Max, can you give me your favorite features about the ZK ecosystem as they currently stand and interface with DeFi?
Well, you know what questions to ask to sketch things out. I mean, I guess kind of interesting stuff in okay space overall. Looking forward to Jolt becoming production ready. They have a fairly different architecture versus the rest of the ZK VMs, the more kind of classic ones like RISC-0 and SP1. So they heavily use SumCheck, which is they found an interesting mechanism to make ZK proving a lot more efficient. And so looking forward to seeing that actually come out in production. Layer 0, the team behind the Layer 0 team, in addition to the Layer 0 interoperability stuff that you have cross-chain, they're doing some cool stuff with their Zero network. They're partnering with the guys behind Jolt to do sort of a custom ZK VM based on the same principles of Jolt using SumCheck, but doing some additional optimizations. I haven't deep dived into the tech behind it yet, but that looks interesting, and hopefully there's some stuff there we can reuse in some of the ZK stuff we're doing. I mean, obviously, I'm excited about the ZK stuff we're working on. So I've talked about this probably way too much for everyone's taste over the last, I don't know how many months, but we have a really cool architecture with what we're doing with Oxygen for ZK proving Bitcoin. And so basically what we've done is we've taken the same EVM ZK proving model, which there's a little more to it and a little more scaffolding, but essentially works over ZK proving operations that use this Ethereum's Merkle-Patricia tree state system behind the scenes. And so that lets you very efficiently authenticate, potentially hundreds of gigabytes of data of blockchain state to a single state root. If you're familiar with Merkle trees, you can think of it like that, except instead of each node having 2 branches off of it or being a leaf node, they can have up to whatever the radix is, like say 16, for example. And there's some efficiency improvements for using a system like that, because the trees are basically squattier, they're shorter. And so you're not recomputing as many hashes going up the tree. And there's some cool stuff with upcoming like Verkle trees to make that sort of system even more efficient in a different format. But from a ZK proving perspective, Bitcoin doesn't have any sort of equivalent data structure to that. And so Ethereum, you can authenticate anything about Ethereum, generally speaking, to anything about the EVM state, at least, to an Ethereum block header that has basically a state root hash in it. There's a couple different state trees, but the point stands. And so with Ethereum, it's super easy to ZK prove, say an operation on that of, running a query on that tree or inserting something into the tree or deleting it or whatever. It's easy to do that because everything's cryptographically authenticated to this one single state root you can reference. And Bitcoin, even though the transactions themselves are always committed to the Bitcoin block in a Merkle tree, obviously, there's no sort of concept of global state or global state root. And so with things like, and this is part of why we built HVM in the first place, was Bitcoin does not make it easy to prove with a lightweight, a Merkle proof or something equivalent, a Merkle-Patricia tree proof or something. Doesn't make it possible to authenticate entries in the UTXO table. And so the only way you can actually look at the UTXO table and reliably produce a proof or convince yourself that something is or is not in the UTXO table traditionally is to go and resync Bitcoin all the way from the Genesis block, play all the transactions, and construct and build the UTXO table through the entire blockchain up to the point you care about. And then you can say, okay, this is in the UTXO table, or this is not. It's either never existed in the first place or was in there and then it's been later spent. And so one of the things with HVM that we did was by embedding a Bitcoin full node inside the EVM, we basically did that Bitcoin full sync inside the EVM, gave the EVM access to it through the new precompiles we added so that you could check if a UTXO is spent or not. And the reason I got off on that tangent is because part of the reason we couldn't just do like a lightweight state proof system where, say, like a sequencer would run a Bitcoin full node, but they could always relay lightweight cryptographic proofs into the EVM for any data that a smart contract queried, is partly makes running a node more complicated. But the main reason is because there was no way to prove this thing is in the UTXO table. And there's some other stuff about Bitcoin too that we expose with HVM that's not provable, but that's the easiest example because it's, tons of data and there's no authentication of that in any sort of structure to Bitcoin block headers. And
now, Max, we do have a question. Thank you for that, by the way, and it's interesting.
The ZK talk will continue until the questions arrive.
Yes, and there will be more floggings until morale improves. Can you tell us, Awesome Canelian, thank you for asking, can you tell us more about Vetro and the plan for Vetro over the next 3 months?
Yeah, so high level, Vetro's deployed. It's in sort of it's not technically beta, like it's in production, but sort of a early launch. We're getting things set up, getting like liquidity indexes, incentive campaigns set up, stuff like that. The way Vetro works, if you didn't hear about it I think I covered this last week or the week before, but basically Vetro's overall architecture is, you can kind of think of it like meta tokens. So there's a token homogenizer with a yield system built onto it. And so what you do is you have a certain class of token like USD stablecoins or Bitcoin or Ethereum. And then there's blue chip tokens in that class that are allowed into the protocol and are essentially treated identically. There's protections in place for if one of them, depegged, stuff like that. But generally speaking, each of them is considered an equivalent first-class citizen in the protocol. And so taking the stablecoin one as an example, because that's the main thing we're going to market with at the moment, and then followed by a BTC product and then ETH product in the future. You would go and deposit, say, USDC or USDT, or in the future, other blue chip stable coins in the ecosystem. And you're basically trading your current USDC, USDT for a VUSD, which acts as the sort of homogenization layer. And then that VUSD, in the background, the protocol is going and earning yield. So it's automatically routing the protocol's USDC, USDT treasury to different sorts of yield strategies, earning yield on those, and then bringing those back to the protocol. And then a portion of that yield is held in a reserve buffer to basically over-collateralize the system. And then a portion of that's distributed to VUSD stakers. So those are people who get the trade USDC or USDT for VUSD, and they stake that into SVUSD, which is the staking vault product, and then they're entitled to a portion of the yield that the protocol generates and distributes to the staking system. And it is also not live yet, but the next feature we'll be launching is a fixed rate, fixed yield product. So not exactly like Pendle, but similar in some mechanics for end users, where basically instead of going into SVUSD and getting variable rate depending on what yield's being generated, say, that week by the protocol, this would be a fixed rate, fixed term product. So you may be staking for, say, 30 days, and you have a guaranteed rate by the protocol. So that's super high level how it works. And then you can just kind of take that same mental model, copy and paste that over to BTC. So it'd be, say, for example, Hemi BTC, CB BTC, and WBTC would be the equivalents to like USDC, USDT, and some other third blue chip stablecoin. ETH, similar thing. Of course, you'd have native ETH, and then you could have potentially at some point maybe restaking tokens, but other equivalent versions of ETH in the ecosystem. That one's lower on the priority list. We're mainly focusing on the stablecoin side and then the BTC side, because that's going to power the Hemi Earn product that we're working on for the Hemi network. But that's basically it for how the protocol works. And then, as far as future features, the next core feature of the protocol will be that the fixed term, fixed rate product. And then just kind of as an ongoing continual thing, we'll be adding more strategies into the protocol so it can go and earn yield in different strategies on Ethereum and across the Ethereum L2 ecosystem.
Now, this kind of may have been covered earlier when you were mentioning the smart contract migration issues, but Awesome Canelian also asks, when will you complete the migration to PopMiner version 2?
It's also coming very soon. We got to get this opgeth hardening release out, and then we can do it after that.
Follow-up from Awesome Canelian, perhaps for Marco. What do you envision Bitcoin ordinals being used for on Hemi?
I feel like I've answered this before, but I'll try again. So what I really want to achieve with the ordinals is to have a data on Bitcoin, so on the Bitcoin chain, and then using Hemi for all the DeFi things that can be done with that. So in other words, we have some sort of value, some sort of amount, some sort of UTXOs living physically on Bitcoin, being moved and being handled by Hemi. That's my V0 version of what I want to do here. So and then with that, the crazy people can take over and build neat and weird and odd things that I can't wait to see.
And like, I want to expand on that too. I think that ordinals and that whole ecosystem around runes has sorely lacked a good UX to interface with it. So building any type of infrastructure or apparatus that makes it easier for people to trade those types of things will lead to higher volumes in those instruments and assets, in my opinion. And I think that that would be healthier for that ecosystem versus the current interface, which is kind of like selling bundles and stuff like that in marketplaces and hoping that they come across the way that that you'd want to. There's really no spot trading for them. Also, ordinals have a capacity to unlock very different and fun layers of programmability for on-chain assets, and so I can't wait to see what Marco facilitates with the stuff he's creating over there. I do see another question, by the way, from the crowd here. Nitraniti asks, when guild tasks or other things will launch, like a hint, Max Boss. You got a hint, Max Boss?
I think we talked about this last week, so we're still having issues with guild. I'll throw it over to John and Joshua. I think we're looking at possibly moving to another platform, but I'm not sure if that's been finalized yet.
So with the number of issues we've had with Guild, we've been looking at other platforms. We're currently looking at Zeally, and one of our moderators suggested another platform that we're going to have a look at as well. So we've decided to continue the beta testing currently, but we are planning on looking at other solutions before launching publicly.
Follow-up from, not a follow-up, but a new question. Does Hemi have a dedicated internal security team?
We do. We have a SecOps team, and we have people on this call who are from it if they want to talk about it further. But yes, we do have a SecOps team. We also have a SecOps dedicated email address. And I see the next question in chat, so I'll just jump to that. We do have an active bug bounty program and a VDP program through BugCrowd. And I mean, we're not going to go into internal details of like team security, which that question's getting into, but obviously following best practices. We've been in the industry a long time. You're never 100% secure, but we've learned a lot over, a decade plus in crypto, and some of the people on this team, decades in programming infrastructure. We have a DevOps guy who used to run SecOps teams for big companies. So definitely following best practices to the extent that it's, practical and applies to the team.
Yeah, I mean, crypto in one sense is still, in the scheme of things, a new space. So there is some amount of we have to discover. So, there's still discovering what the correct security posture is for crypto. And a lot of it is the common sense things, which we do. And some of it is the industry standards, which we, do our best to follow. Some of it is we're all figuring it out, learning as we go along. And in a sense, we're almost writing the best practices. So when you take multi-sig security, a bunch of us have been there since there was no multi-sig security. So we follow the best practices, but we were also kind of there when people were coming up with them. So we are, clearly doing the shit we should be doing to the best that we can. Nobody's security is perfect. If you say that you're, if your ship is unsinkable, we know what happens with that. So we're never going to say we're that. But, and I'll even answer that question about SOC 2. I don't know what SOC 2 for a blockchain would even mean. So I just don't know what that would,
But they are interested in SOC 3.
Fuck it. Let's, go with SOC 4. Like, I don't fucking know what that means for a blockchain. Is your Bitcoin SOC 2 compliant? I don't fucking know. I'm not clear. It's not clear that question makes sense for the, SOC 2 is, I'm sure it's wonderful for the types of things it's wonderful for, but, not every, security, SOC 2 is not really a security standard. SOC 2 is a different kind of standard, but, let
me throw this one out there. What is that for those of us who are uninitiated with what SOC 1 even is?
It's one of those corporate standards that some that large corporations like it because it lets you say you have followed some set of checklists to say your internal practices follow a certain set of checklists. It's, so if you're going for certain corporate things, it is very useful because it means you can prove that you've done certain things. In terms of actual security, like stopping hackers and stopping people from abusing things, you know what? It's a checklist. Checklists are great. They prevent surgeons from leaving, cotton balls and tools in you when they open you up, but they don't stop everything either. So, we try to follow what's useful, and SOC 2 is expensive. It's not necessary. So it's a question of, is that where you spend your limited resources? Again, does it make sense? Can a blockchain be SOC 2 compliant? I don't even know. I'm not sure that makes sense, but so we try to follow the best practices. We take security seriously. We have a lot of cranky, paranoid people here, which is what you need to be secure. So that's what we got.
And I'll say there's some things that, and again, I'm not by any means a expert in SOC 2 or even anything close to it. There's probably some things in there that could be applicable to like infrastructure rerun. But the general goal of any blockchain, Hemi included, is get, like JSV was saying, is Bitcoin SOC 2 compliant? The question doesn't even really make sense because Bitcoin is truly decentralized. There is no company running Bitcoin or anything like that, or a team behind Bitcoin. There's developers who contribute to it. There's people who argue endlessly on forums about what updates should be made to the protocol. But there's no, the concept of SOC 2 doesn't really make sense for Bitcoin. So, the goal for Hemi, could there be a few things in there that are useful? Absolutely. Are we doing a lot of them not formally under SOC 2? Yes. But the end goal is get Hemi decentralized to the point where that question doesn't make sense in the context of the chain. And usually, and even in the current situation, especially as we roll out like some of the ZK tech, stuff like that, what will become a lot more important, or is already more important in some aspects than something like an enterprise style compliance, would be, what's the rigor of audits that the ZK circuits have gone through, stuff like that, which, enterprise compliance doesn't cover stuff like that. Enterprise compliance is, how do you run your databases? Who has access to them? How do you run your server? How is your infrastructure secure? What security operations do people in the team undertake? What kind of security audits do you do for people who are on the team or their dev machines? And that stuff's important, and we do a lot of that. But more and more, it's going to become, is the protocol written correctly? Are the ZK circuits written correctly? Are they audited? How is the governance process working for upgrading things on chain? What is the permissions of, deployed contracts, their upgradability, emergency, intervention powers, who controls those? And those are the kinds of things that maybe we need like a new blockchain standard that's the SOC 2 version of, blockchains or Ethereum L2s or something. But the SOC 2 has good stuff. But
No.
There's a ton beyond it that, well, Marco, what I'm talking about is like, how decentralized is the network? What are the, it'd be things that as you decentralize, you meet. And we kind of have that with things like L2Beat, their rating, things like that. But, getting to something like SOC 2 applied to a blockchain as it becomes decentralized makes less and less sense. And there's a new list of things that matter a lot more than that, or should matter a lot more.
No, I was kind of somewhat kidding, but I think that John's answer was about as accurate as it could be. It's, there's no need for NIST in Bitcoin.
Yes. And in fact,
we got
Bitcoin actively avoids NIST.
Yeah, we got it. And, so let's get, let's keep the government out of my Bitcoin.
I'm talking more like community standards. Like we all agree, here's how we're going to rate these systems. But yeah, I don't want NIST coming in and coming up with, not that they have time for it, thank God.
Now,
well, they certainly have time to water down curves and make them less good.
Yeah, I thought that's exactly what they had time for.
Yeah, the N is for not working.
We don't know where the numbers came from. A guy generated it on his computer, and then we lost the computer. I'm sorry.
I mean, government agencies can lost computers wouldn't even surprise. That's the scary thing. That is almost a believable excuse.
I mean, there is a lot of bureaucracy. You're like, okay, fair.
I mean,
Generate new numbers then. How about that? New curve parameters.
I mean, when I was in grad school, I got an email about a very large laser that they thought was missing, that they thought might be in my office. It's like, no, I don't have a fucking laser in here. But again, if a state university can lose a rather large and expensive laser, I can imagine a government agency losing a computer.
I'm sure you were the first person on their list of people who thought like might have taken a laser.
And you should have. I'm just saying.
If I had seen the laser, maybe. I never saw it.
If you guys are going to blame me for taking lasers, I think I might as well take them anyway. Now, Logan Michael Harris wants to know, and I think you're talking about quantum leanness, Vitalik. He says, hey, Vitalik released quantum lean, I believe that he's talking about. Will that influence Hemi or other Ethereum chains, is, I believe, his question.
In general, yes. I mean, there's a lot of good stuff in the whole Ethereum or post-quantum, quantum-resistant proposals. So short answer, yes. I think we've talked about this in previous weeks.
So yes, but not for the reasons they mentioned, but yes.
Generally, yeah, I'd agree with that statement. There's a lot of cool tech coming out of it. So we get back to ZK provability a little bit. All of the compact ZK proving systems that are used in blockchain today, there's probably an asterisk. I'm sure somebody's not doing this, but in general, they're all vulnerable to quantum computing attacks. So anything like, Groth 16, for example, these pairing-based ZK proving systems, even if there's a quantum resistant, or thought to be quantum resistant at least, based on our current understanding of quantum computers and what they can do and not knowing an efficient algorithm, which that's a whole other problem. But even, like ZK proving systems, you'll hear RISC-0 is quantum resistant. It is, but only for the Stark proofs, not for the Stark to Snark wrappers using something like Groth 16 that you then verify on chain. And the reason for that is currently the proofs for all of the known believed quantum resistant ZK systems are too big and too expensive to validate on chain in general. One of the big things that's part of the lean roadmap is working to develop at least practically sized. They're not going to be as small as the existing nice ones we have today, like Groth 16, I'm sure, but developing smaller Stark-based ZK proving systems where the proof and the proof verification complexity is a lot lower. And so that it'd be great for Ethereum to update and support those and add in, precompiles that accelerate verification of those. There's a lot that would then let you build a post-quantum secure ZK bridge or ZK tunnel from an L2 to the Ethereum network. So that's cool. There would be changes to the EVM that would make it easier for our network to support those other post-quantum proving systems. That'd be cool. That lets you build more stuff on top of Hemi that's quantum resistant. And that we would just inherit as new features in the EVM that Ethereum is working on. So there's definitely stuff in there that would be useful. That being said, and there is some active research, like there is progress being made in this front, but I from everything I've seen so far, I do think we're pretty far away from like practical, small enough quantum resistant ZK proving systems that are so small you could use them on chain general purpose. I think what Ethereum is, one of the things that makes Ethereum really hard to make quantum resistant is if you look at Bitcoin, for example, the only thing Bitcoin has that's vulnerable to quantum attacks is the signatures on transactions. And so when you make a Bitcoin transaction, you sign it with, say, using ECDSA or now using Schnorr. And both of those algorithms are vulnerable to quantum computer attacks. And so even if you use something like, paying to a script hash, so the actual public key is not revealed until spend time, there is still a transient period where that transaction's in the mempool and exposes the public key, which is all you need. If you do have a quantum computer that's big enough and powerful enough to break ECDSA or Schnorr with the number of bits of security Bitcoin uses, then you could go and basically snipe that transaction, get its private key, and submit an alternate transaction to the mempool that pays higher fees, steal the Bitcoin. And obviously for Bitcoin addresses that have already had their public key or public keys exposed by spending, or like legacy pay to public key transaction output types. Those would be vulnerable from when you get the quantum computer to when you do the attack, right? But the only thing Bitcoin really needs to do to solve quantum resistance is introduce a post-quantum signature algorithm. And like we talked about in previous weeks, you actually can verify at least one type of post-quantum signature on Bitcoin. You can validate, you could write a Bitcoin script that validates a Lamport signature or a Winternet signature, which is just a Merkleized. It's more efficient. It's not Merkleized. It's a more efficient form of a Lamport signature. And you can also do a Merkleized Lamport signature too, to have multiple different unique one-time use keys that you can use. So you can do that, but you can't, in the Bitcoin script, associate that with the transaction you're spending. And so it doesn't make Bitcoin post-quantum, even though there's ways you can use it that are interesting. It's still, even though we can do it on Bitcoin, you can't check that signature matches the transaction. So somebody with a quantum computer could still snipe your one-time signature of something and replay that in their own different transaction. But all Bitcoin does need to do to become quantum resistant. And again, I don't think quantum computers of the size needed to attack Bitcoin or Ethereum are coming in the near future, but now's the time to start.
Or lifetime?
I
am very skeptical.
That's
the only thing I want to add to that.
A while.
Yeah, I really am extremely skeptical about the whole quantum computing thing. It seems to be your typical, academic masturbation circle where, they need funding. So there is a breakthrough every week, and the breakthroughs are indeed weak. Every time you see something, you read the paper and it's complete nonsense. It's prefabricated numbers. It's just crap. I have not seen anything that points that there's anything that actually does literally anything useful. So until I see any evidence of actual progress, I am going to remain full on skeptical. I mean, this is like string theory. I mean, those guys have produced nothing in 30 years, but they need funding, so they just keep making up shit.
I mean, the string theory papers are confusing as fuck if you've ever tried to read one. But yes, there have been nothing useful came out of that. And yes, the quantum ones where they can factor a big number, but it has to be the big number that they chose and know the factors to, always feels a
little contrived.
Yeah, just a bit. Although what I was going to say is, it mentions that lean Ethereum thing. I was reading that this morning, and I'm confused how adding a whole bunch of things to Ethereum is making it lean. I didn't see any mention of removing anything from Ethereum or anything that simplifies the protocol or cuts anything down or actually makes it leaner. Unless I missed something.
No, it's leaning because it's
like
got
the
more
Tower of
stuff
Pisa?
on it. Yeah, so now
I don't think that's what they meant.
It's Ethereum lean because you put all this stuff on one side, and now it's user ZR5GE5 asks, between Monero and Zcash, which would you consider better designed? Especially consider the FCMP and Zcash's team's link.
Before I get to that question, just to close out the lean Ethereum thing super quick. The one thing that you can consider is becoming more lean is, even though the protocol is becoming more complicated, and the ZK proving of the future lean Ethereum protocol or variants of it versus like trying to ZK prove what we have in Ethereum today is going to be heavier with post-quantum ZK proving systems and whatnot. They are trying to architect it so that it's easier to run a more secure thin client. And so, again, they could do that without the post-quantum stuff. It's there's a lot built into lean Ethereum, but trying to simplify down, beacon chain consensus for the purposes specifically of light clients using ZK proofs. That specifically is leaner in a certain context of using it. Does it make the protocol leaner? No.
Isn't that at the expense of making a full client even? I mean, as is, Geth plus a beacon chain is possibly the most morbidly obese piece of software you could ever, or set of software you could run. So you're making a leaner light client at the expense of the regular client, the full client being even less lean.
Which is usually the trade-off. And yes, fundamentally, yes, it makes it. Ethereum doesn't have ZK proving natively in the protocol. You could ZK prove the Ethereum protocol and use that like to create a new Ethereum client. But fundamentally, the structure doesn't make it less computationally expensive to run a full node, but it does by design make it easier to run a light node by moving more work to the full nodes, making them do ZK proving, and also ZK proving in a basically near or at the tip of the blockchain, which currently, and we've seen like tech demos of people doing real-time proving with like giant GPU clusters. We'll see how that affects decentralization, but yeah, won't go any further down that rabbit hole today. But yeah, it's Ethereum is not becoming lean. You can just have light clients with better security because you're shifting more complexity in the protocol and more compute onto the full nodes. So whether that's lean or not, that's a judgment call, I guess.
All right, now let me see if I can read this question right this time. Okay. Between Monero and Zcash, which would you consider better designed, especially considered God, I did it wrong again, FCMP and the alleged Zcash's team's links to the CIA and alleged links to Israeli intelligence?
I'm not super read up on especially Monero, and I haven't followed a lot of the recent Zcash stuff too closely. I personally lean towards Zcash. I know John's gonna have a different answer, so looking forward to his, because it's closer to the Bitcoin protocol itself. So it's just easier to understand. There's less new moving pieces, even though obviously a lot of the ZK tech stuff is new and moving. And we saw like the exploit in the Zcash circuits, 6 weeks ago, something like that, which have been latent in the code base for years and nobody had found. So, there's always risks like that. I think not super familiar with their recent upgrades, so I can't speak to the technical side of that. One thing I would like to see with Zcash is I forgot the exact time, but they forked off of Bitcoin and they kept up to date with new Bitcoin features up until I want to say like 2018 maybe, and then they stopped, adopting new Bitcoin upgrades. So Zcash has the regular non-shielded Zcash tokens, which are very Bitcoin-esque. They go into Bitcoin scripts. They're spent using spend scripts for Bitcoin scripts. So everything there is almost equivalent to Bitcoin minus some recent features. And then you have the shielded protocol, which is operating entirely in the ZK circuits, and it's an entirely different system. You don't have script execution in there. There's no like programmability inside of the shielded system. It's just transfer of assets around by proving that you're spending an unspent chunk of tokens and then proving that you're not sending more than that number to somebody inside the shielded system. So basically proving the accounting is correct without revealing where the tokens are going. I would have liked to see them keep up with more recent Bitcoin features, because one of the side things I looked at a while ago was if it would be possible to build like an HBit VM style ZK bridge or ZK tunnel to between like Zcash and say Hemi L3. And the short answer is, since they don't have stuff like TapScript and SegWit, it makes Covenant emulation hard to impossible, and it makes the BitVM2 style design of how you split up the giant ZK verifier program into a bunch of leafs and put them all in a tap tree. It makes that you can't do that because there is no TapScript tap tree functionality on Bitcoin. And so it would have been cool if they kept up with those upgrades, because then any of the Bitcoin tech we build, we could Control-C, Control-V over to Zcash. And the current reality is, since they didn't keep up with those upgrades, the only way you can build like a ZK bridge or tunnel from Zcash to another network is using like a much more inefficient OG BitVM1 style design. So that's kind of a tangent, but for the part that's applicable to Hemi, it would have been cool to see them keep up with those Bitcoin features, so at least we get BitVM2. They do have some features that they've added that Bitcoin did not adopt, So like they have a different way that they do time locks in a way that could be used in an interesting construction, but it's not enough to build a BitVM2 style system on top of it. That's nothing to do with the privacy tech. That's just what I wish they did at the unshielded layer. I'll throw it over to John because he likes Monero, and I do too. I don't know it as well.
Yeah. So I think you've got too many pluses in that full chain something proof there. I'm pretty sure it's only got 2 pluses, not 3. But so my main thing with Zcash was always ignoring the conspiracy theories about it, which may or may not be true. I certainly don't know. If I had deep knowledge of the inner workings of the CIA or the Israeli intelligence agency, I like to think I could monetize that better than writing crypto software. But
I mean, you wouldn't tell us here.
that is also true. But anyway, like my issue is always Zcash is opt-in privacy. Monero is privacy by default. And by having the opt-in, it means some large fraction of your chain is always going to be not private, which means you have a better sense of what the overall transaction graph is compared to Monero. Monero's ring signatures where, you're mixing 16 transactions, I think, in one, some number like that was good. The new one is that full chain membership where it's mixing the entire UTXO set is, I think, an even better one because through whatever math magic they keep the size relatively small. And I haven't gone super, far down that, but you've made the set of transactions that you're mixing so much higher that even if you can have some reason because you have certain transactions of your own that you're putting in there to be able to follow, that doesn't give you any actual useful info about the rest of the set. So I really like that full chain proof, that full chain membership proof with a couple pluses because fuck it, this is computers. We like lots of pluses, right? Thanks, C++. Look how you've ruined everything. That gives you a really large set of mixing for the privacy. So I happen to think that's a really good method for for non-opt-in privacy for transactions. Yes, it limits what else you can do with the chain, but if there's one thing we should all know by now is there's a cost to privacy. It's not like you don't get it for free. You actually have to, that's why Bitcoin transactions aren't private, because there is some additional cost, whether it's in terms of complexity, capabilities, transaction size, something. There's always some trade-off and some cost to it.
And I would say with, and again, not having done a super deep dive on it, but now that Monero does have the full chain membership proofs, that was one of the concerns was, if you're only mixing in like a small set versus, okay, Zcash, a lot of the tokens aren't shielded, but the ones that are kind of in this one homogeneous pool that can't be tracked. Now, I would argue probably with SCMP++, Monero has better privacy because it's always the entire set, which is similar to what you get with the ZK style system with Zcash. But since everyone in the network is opt-in by default, forced to opt into the protocol if you want to use the chain, you do get a larger set versus what you get with just the shielded side. So previously you could argue the shielded side, even though only part of it was shielded, it still made sense because you were always operating within the entire set of shielded coins from a privacy perspective, whereas with the previous Monero style ring signature construction, you weren't. But now I would say Monero is arguably ahead, but that's not a extremely informed tech side opinion.
Now, I kind of was interested in shifting the conversation to something of a current event, as some of you may have been paying attention to the events that took place with the Bonk DAO debacle. I'm curious about governance and just what we can learn from that and how we can move forward in an ecosystem and prevent these types of hijinks from occurring. Would you guys care to share your thoughts on this matter?
I have not been following BonkDAO specifically. I saw a headline about it, but I have not read any details. So I don't know what exactly went wrong in their system.
The long and short of the story is someone used their existing governance architecture to buy an outsized number of votes, submit a proposal that would have transferred control of the treasury to them, more or less, and then used their like $4 million buy-in to influence the voting so that proposal would pass, and essentially took $20 million by spending $4 million.
Okay, so basically the same, like you pay to take over governance attacks we've seen before.
Yeah.
A couple of initial thoughts. Again, I don't know exactly what Bonk's DAO architecture was or how they were trying to prevent this, but in general, those sorts of attacks usually are only either possible or practical when there's either a very low amount of governance participation, or it's very easy to get in and out of the token or in and out of the governance position. And so one of the things, and this is partly why we structured VE Hemi and in the future VE Vetro, which is going to be the same architecture around the vote escrow system, is because you can't just, and again, I don't know what exactly went wrong in the Bonk case specifically, but we've seen DAO exploits in the past where somebody goes and buys up a lot of tokens, or even I think there was a case where somebody was able to, like way back in the day, do a flash loan of the tokens from a protocol and then vote on proposals and things like that. So when you have an architecture that heavily weights the voting weight of a participant, not just based on the number of tokens they have, but on how long they're locked up in the system, again, it doesn't make it impossible. Somebody can go and buy a ton of tokens and lock them up for a very long period of time. But it makes it a lot harder and more expensive because you're buying tons of tokens, and then, if you are attacking the protocol and destroying it, those tokens are probably going to go to zero, right? Which is kind of the security argument around Ethereum proof of stake as well. Like if you own 2/3 of the Ethereum proof of stake consensus power and you attack the network, well, it's not, even though you're not going to get slashed because you control all the blocks created after that point, because you can exert full censorship control of the network, the Ethereum that you're holding is probably going to be worth a lot less now that you attack the protocol. And so in general with DAO designs, that sort of longer term lockup, obviously not letting people vote based on liquid tokens, because that's where, if you don't structure it, you get like flash loan attacks. But even you can guard around that technically. And even then, it's very easy for somebody to get in, do something, and then quickly exit and not suffer like the economic ramifications of their stake, because they're no longer staked in the system. So that's why designs like VE Hemi, where somebody who's staking for 4 years gets, 8 times the multiplier of somebody staking the same number of tokens for 6 months, for example. So make sure the people involved, the people voting who have the most weight in the system, are economically aligned or should be economically aligned with the system long term. And then the other answer is, while a DAO is still developing, so when you get to large scale and there's tons of participants, and it's almost impossible to acquire enough tokens at any reasonable rate to do anything malicious to the protocol, that's one thing. But how you get there, I think the best design is usually having some sort of security council or veto council. So you have governance that can control very slowly, kind of like how you have in the US, you have the Supreme Court, which, once somebody's appointed to the Supreme Court by the president, they are in there for their life or until they decide to retire. So that can be 20, 30, 40 years. And the idea with that sort of a model is you may have very rapid changes in one part of the government, a la, the executive branch, you get a new president every 4 years kind of a thing. But the fact that people are slowly appointed over time and then stay in the system for a long time as a check and balance, a la the Supreme Court, that gives you a lot more protection against, say, a rogue attack on the protocol. And then you can still have things built in. So if the Security Council is themselves being malicious, you can set the threshold where the community can override them or vote them out or change their composition, such that nobody can do that from a standard attacker sense. But if there's a legitimate community need to remove or change the composition of the Security Council, they can still do it, but it's going to require such a high threshold that in practice, it's most of the community actually agreeing. And you can also put in, time locks and time delays and other things that help with that balance of power between the DAO itself, some Security Council making sure that bad decisions don't happen, but ultimately that Security Council does operate at the request of an approval of the DAO, because they do have control over the composition, but it's on different time periods and requires high thresholds to change. So not a perfect system. Anything that is decentralized enough is also vulnerable. I mean, Bitcoin, 51% attacks, Ethereum, supermajority of staking power. So you can't protect a system. You only can protect it within certain bounds. And the other thing is, as you're decentralizing a protocol, you have to make sure that the economic damage, to the extent that it's possible and that you can pre-plan this out as kind of a stage roadmap, that the economic damage somebody can do by taking over control of governance is smaller than the cost to take it over. So for example, you don't want to put $100 million of protocol assets in a DAO that has, $100,000 worth of tokens that are, voting or that constitute quorum to make decisions. But if you have a DAO that, say, initially mostly controls technical aspects of the protocol, like updating a V key for a ZK proving system, or allocating some small amount of funds to different community initiatives, and then as the DAO grows in security, more tokens staked and staked for longer in the system, then you can shift more important economic decisions over to the DAO without creating an imbalance of power where the cost of attacking the DAO is lower than what you can gain from the types of attacks you can do with the DAO's current structure and assets. Not a perfect answer, but you have to think through it in stages.
I've rarely seen a DAO function that has a large, large slush fund in it or something like that, in a way that actually facilitates the proper use of those funds to make projects work. A lot of times they sit there, they don't collect any, yield or anything like that. They just sit there stagnant, waiting for someone to either reappropriate them or, in this case, to find a way to siphon them. So I like what you're saying there. And I think what you said about, partitioning the funds across multiple different verticals, I think that makes a lot of sense too.
And also, I mean, obviously it depends a lot on what you're using the DAO for. So like for Hemi, for example, one of the main reasons that we're going to need and want to decentralize DAO is so that like protocol changes can be voted in and adopted, right? Like adopting a new ZK proving system or adopting an upgrade to a circuit because of an Ethereum upgrade, things like that. And those are much harder, not impossible, to attack and like make money off of, because if you break a system, there's always some amount of money you can make from doing that, right? But it's a lot more difficult and convoluted than, buy $1 million, vote to send yourself 10 million kind of a structure. And so then the other thing too is, again, depending on what kind of protocol this is, but this applies to, like, say, Vetro, for example. The system, the way Vetro works is the protocol controls the funds through very, specific approved routes, right? And so it's not just like a, like a DAO governance and something like Vetro would not be, hey, there's a treasury of tokens, what do we do with them? It's, how do we allocate them between these different approved strategies, for example? And so that, again, you couldn't compromise the governance to just withdraw the tokens because they can only go into certain set grooves inside the protocol. So maybe you can move them from, liquidity mining on, this DEX LP position to putting them in this lending market. But that's not an attack. That's just you voting to shift like the protocol's portfolio composition. And so it depends a lot on what you're doing the DAO for, but I would agree with Jeremy. Like generally, DAOs where they just say like, here's a bunch of funds that the DAO controls, go do the right things with it. That's usually a dangerous model. There may be ways to do it right, but that's a lot harder than things that are like protocol upgrades or allocation of assets within very specific like grooved paths, if that makes sense.
Now, what are the reasons you might want to turn over such things like features and updates to the protocol to a DAO-based process versus just have them implemented by founding protocol engineers?
Yeah, I mean, obviously one is the goal long-term for Hemi is to be just completely decentralized where, we're on here chatting about some, code we're working on that we think should be part of the protocol and hoping the community approves it. So that's ultimately, takes a long time to get there. But that's the ultimate goal is we don't control it. We, if we get hit by a bus, hopefully someone's interested enough to take on, development of the code, make sure the protocols get, the protocol gets upgraded and features get added and, governance is organized around that. But so part of it's just, we want the system to be fully decentralized. And then part of it is, as a project, like one of the benefits of decentralization is resilience. So even if you don't per se care about decentralization, not having, specific servers, and again, we can argue about how much of Ethereum is run on like AWS and GCP if we want, right? But in general, like decentralizing a network makes it not only better from it is decentralized, people have control over it, or nobody specifically has control, but collectively people have control over how the protocol evolves, like we have with Bitcoin. But also from a resilience perspective, like there's no single, and again we have redundancy and stuff, but in general speaking, like there's no person who can take a part of the network down. There's no person who can, there's no like data center outage that could take a large portion of the network down. Again, we can get into AWS and GCP for Ethereum nodes, but in general, like having that resiliency of you have tons of people running nodes all over the world doing different things, staking, sequencing blocks in the network, performing all the functions that make the network function, even if there is like major global internet outages or internet partitions for periods of time, the system can still work and eventually converge. So resiliency, and then just you want things to be decentralized and for the community to control it to the extent that that's technically feasible.
All right. Well, I think that we're pretty much at the top of the hour just about here. We can probably call that a wrap on this episode of Midweek with Max. Tomorrow, you can catch us the same time that we schedule our regularly scheduled protocol engineering office hours that will be streaming on X, LinkedIn, and YouTube as well. Join us there if you're building something cool on Hemi and you want some answers from these fellas, and I'll be there to help host. And when we don't have any questions on it, I think JCV, I was going to ask you about the diurnal change on Bermuda grass and how you might want to be managing that, as well as pH levels. Do these affect grass growth? We're gonna find out. We're gonna find out tomorrow. So tune into Protocol Engineering Office Hours /Lawn Care here on Hemi, and then I'll hand it off to everyone else for outros. Max.
All right, cool. Appreciate everyone showing up for another Midweek with Max, and we will see you not tomorrow, but next Wednesday for engineering office hours. We're going to be doing them every 2 weeks now. Right. Sorry, I wasn't listening when you said so. If you said next week,
I thought it was tomorrow. I made a mistake, but that's okay. We live, we learn, we grow. Amazing.
But if you do want to be part of that, join us next Wednesday, same time as Midweek with Max, just Wednesday instead of Tuesday. And of course, we will see you at Midweek with Max next week. And I think those are the main things. So I did want to do a demo of the ZK Prover Marketplace. There's one component that I was trying to debug during this call, and I didn't quite get it up and running. So I will be posting a probably video to Discord instead, and then it's a little more permanent and like self-contained too. So stay tuned for that. For anyone who asked about there's a person who asked about the ZK market last week and was asking for a demo. So if that's you, or if you're interested in that, stay tuned for that coming out. And beyond that, appreciate everyone showing up, and we will see you next week.
Thanks, y'all.
Cheers.